Okay friends, today we start a screw jack assembly. There are 7 parts in the screw jack assembly. The first one is body. This is body part, and second one is nut. This is a front view and top view, and this is a screw spindle, and the fourth one is cup. There are 2 views, front and top views is given, and the fifth one is washer special, and sixth one is CSK screw, countersink screw, and seventh one is at the last Tommy bar. Then how to create the parts individually? First we'll go for open the Solid Edge ST9, then click on the metric part, ISO metric part, go for the tools, select order, then go to home and click on reference planes, then switch on the drawing. See the body part. I start with the body part number 1. The overall height is 185 and this diameter is 50. We have to construct the sketches. What is the edge portion is there, no etching portion, that much you have to construct. This is 50 by 2, this is 70 by 2, and height is 40. Then this is 66 is given. Then from the bottom, from here to here is 100 and here to here is 140. We have to take half of that, and height is 20 from 100. I'll go for sketch first. Sketch, click on front plane, take this height from the center, overall 185, then click fit. This side it is 25, 50 by 2, then 35 by 2, then downwards it is 40, then this side it is 2, because 35, 70, from here to here it is 66. 70 minus 66, 4 by 2 is 2, it is 2, and stop. Then I'll start from the bottom, zoom. From here there is a 3 mm gap is there, 3 mm. I'll choose upwards 3 mm. Then this side it is, see, it is 100 and this is 140. 100 by 2, 50. Then move downwards 3 mm, and this is 20 again, then 20, then this is also a 20. Then click fit and connect to this. Okay, now see, there is a offset for this. There is a 10 mm offset. Before that I'll draw a line from 25 mm line. You draw one line approximately at length, for this is 25, and go for offset. For to take this 10 mm inclined line, I'll go for offset command, click 10 mm is the offset distance and single. I'll choose only this line to make offset. Click accept, click inside and escape. Then go for extend command to extend this line up to this. Then zoom and trim off the extra lines. See, trim. Now click fit. You trim off this line, you trim off this line. Since I construct only the hatched portion, this is a hollow and this is required for axis of revolution. This is axis line. Now I'll show the dimensions. Go to smart dimensions. This is 185 is given, this is 20. Zoom and give the dimensions. What are the dimensions is given, and this is 3 mm is given, right? Go to distance between, from here to here is given 100 by 2, here 70, 140 by 2, this is 140, this is 70, this is 100, 50, and height you have to take as it is. Then one more distance is given from here to here, it is 50 you are given, and from here to here is 66, from this point to this point, see, 66 by 2 it is 30, and in the top there is one more, from here to here is given 25, 50 by 2, and here to is given 35, 7. Here to here is 35, 70 by 2. Then click fit, then close sketch, go for revolve, revolve, click finish, click fit, click on revolve, then here you choose select from sketch, click the sketch, then accept, then this is on this axis we have to revolve for a 360 degree. You type 360 degree here, or in click revolve 360 by default, click finish. Now you go for round, you give this corner round option is given, radius is 8, then radius is 8, click preview and finish. Then one more step is, there is a small fillet radius, you can give that radius is 2 mm, click preview and finish. See, here is a small fillet, and then click fit, then close sketch, hide the sketch, hide reference planes, hide base, then you will see the part like this. Now we'll go for, if you want give the color, go to color manager, choose any your favorite color. I choose copper or brown, gold, brass, anything. Okay, for I'll choose, for my body part I'll give gold. For the material, you add the material here, since it is a cast iron, you can add cast iron. Okay, material table, give cast iron here and apply model, then save the body part, keep it in isometric wave and save the body as body. The part number 2 is nut. See, the overall height of the nut is from here to is 45, here to is 50, here take radius 50 by 2, this is 90, here to is 90, 90 by 2 45, here to is 10, here to is 10, and close and make a thread. Now I'll go for revolve first, since it is a circular, go for revolve, select front plane, take the height 45, this is 50 by 2, then 10, this is 90 by 2 45, 25 already taken, 20, then downwards it is 10, then close the sketch, this much. Now show the lengths, okay, this is 25, 10, 10. Now click on axis of revolution, this is my axis center, then close, enter 360 degree, now finish. Now you choose for radius to make this round, to make this fillet, click this corner, click this corner, click this corner, your radius is 5, then preview, finish. See, now we'll go for hole option, hole, click OK, select top plane, hole option, select top plane, options, then choose threaded, here you choose C, the thread is square thread, diameter 38 by 7, go for square thread 38 by 7, move downwards, 38 by 7 is the pitch, then click on to wall extent, to wall extent and click OK and place it in the center. Close sketch, move downwards, then finish. Now add the material and save the part as nut. The part number 3, the screw spindle. Screw spindle, the overall height is 240, then this is 22 and this length is 65, and from here to here is 83, and there is a 2 holes. Here is a threaded hole and there is a thread in the spindle, that is square thread, 38 dia into 7 pitch. This much we have to construct. Either you go for sketch or directly revolve. I will go for sketch first, then choose plane, front plane. From here I take height is 240, then click fit. This is 22, this is 22 by 2, 11, and downwards this is 13, and this is 65 by 2, overall 65 by 2. Then more length 70, total length is 83, and this is 13.5. Click fit and close. Now you check the dimensions, go to show the dimension. This is 240, this is 19, 38 by 2, 19, small dimension, this is 11, this is 13, from here to here it is 83, and this is 11. This much dimensions. And to make this chamfer, there is a chamfer 45 degree, 10 by 45 degree. Here is the chamfer. Setback is 10 by 10 and angle is 45 degree. Zoom, click this line and this line, make it 45 degree. This line and this line, make it 45 degree. Now close sketch, go finish, then revolve from sketch, select the sketch, accept the center button or click right button, 360 degree, finish. Now hide sketch, go for thread, okay. On this cylinder, click this end point. If it is any offset, you can give from this end, otherwise you can choose this end is the starting of the thread and choose 38 by 7, click finish. For one more hole command, select this top surface to make this hole, to make this countersink hole. Go to options, see M12 is given and height is given 35, hole height is 35, thread height is 30. First you go for threaded, choose M12, okay, 30, here it is 35, and choose V bottom, click OK, place it in the center and click close sketch and finish. To make a chamfer, go for chamfer, select this and bottom of thread here, choose 2 mm chamfer, click finish. You get like this. Now go for cut, select front plane to make this hole of dia 12 mm. dia 12 at a distance of from here to here it is 35, here to center of the thread is 35, and the hole diameter is 12. Make a through cutout symmetric both side. You can click symmetric extend, through hole, finish. Make opposite side one more hole, select right plane, same diameter hole, dia 12 and distance is from here to here it is 35, and 12 symmetric extend, finish. Right, now the screw spindle is ready, and add the material and save the part as screw spindle. The part number 4, cup. The height of the cup is 42 and top diameter is given here 65, and the bottom diameter is 45, and there is a hole of dia 12, and this height is 12 and this height is 6, and there will be a cutout. Go for revolve, select front plane, from here to here it's 22 by 2, that is 11 for the whole height, and this height is given 12. Then from here it is 45 by 2, then this side approximately you can take and draw one line like this. If you want to zoom, show the dimensions first, give from here to here, this is 45 by 2, and here to here it is 22 by 2, and the height is 42, and this top diameter from here to here it is 65 by 2, 32.5. Then there will be a 6 width. I will go for offset for that. Offset single, here is the 6 width. Accept, click inside, then you close this line and trim the extra lines. Trim this extra line, zoom and trim off this. See, this is actually the given. Then trim off this also. This is close sketch, make it 360 degree, revolve, then finish. You see, there is a cup, there is a hole here, there is a cutout. Go to cut, select front plane, draw a diameter from this top, then click return, cut symmetric extend both side, click finish. Do same cutout opposite plane, circle, you draw one circle for a dia 10, check the dimension, dia 10, then close sketch, then through extend, cutout symmetric through extend, then add material and save. Part number 5, washer. Since it is a circular and very simple sketch, then we will go for directly revolve. See, the outer diameter is 35 and the height is 8 mm. There will be a countersink hole of dia 25 by 14.5 bottom side, and angle is countersink angle is 90 degree. Now we will go for a revolve. Since it is simple sketch, from here to here 14.5 by 2, 7.25, Then there will be a height, approximately you can take one height and go for angle, any length. Angle is 45. On this side just move, connect. I will trim off this and give the dimensions now. Go to distance between this line to this line is 14.5 by 2, that is radius. This is 35 by 2, 17.5. And this height is given 8 mm. Here to here is given 25 by 2, that is 12.5, and the angle is given 90 degree. Go to angle between, click this line to this line is 45 degree. At least 45 degree. This portion you have to construct. Then go for revolve axis. Okay, this is the revolve axis. Close sketch, then 360 degree, then finish and save. Apply the material. Okay, next part number 6. See, countersink screw. See, there will be a height of 30 mm height. The top diameter is 24 and the bottom it's a M12 metric 12, and there will be a countersink height is 6 and 90 degrees given. It's a simple revolve. We'll go for revolve. Select front plane, take the height as 30 mm height and diameter is 24, then radius is 12, then this is 12 by 2, 6, and this is 30 minus 6, 24. Then connect it, show the dimensions. This is 6. Here to here it is 6, and angle is 45 degree. This now revolve axis of revolution is this center axis. Then close sketch, then 360 degree, finish. Go for third option, select the, then click right button, click the start point of thread, then select M12, then finish. Go for chamfer. There will be a chamfer here, threaded portion, chamfer. Select one 1 mm chamfer, click finish. Next, there is a cutout 3 mm height and 2 mm width. It's given in the dock. Go to cut, select any one plane, zoom, go for rectangle, give width is 2 and height is 3, and place first, then move from this center to this center. Small dimension, this is 2 and this is 3. Then close sketch, click symmetric cut, then finish and save the part as CSK screw and apply material. Part number 7, the tummy bar. The length is 275, diameter is 20 and other side it is 12 for a distance of 62, and there will be a 45 degree. Go for revolve, select front plane, start from the center. I take this side, it is 62 and height is 6, 12 by 2, and close this 62 and take any length for a angle is given 45 degree. Then I'll skip this, start from this side, take overall length 275 plus 62, and this side it is 20 by 2 10. Then close and trim this intersection, right? Now show the dimensions. This side it is 6 and this length it is 62, and overall length is 275. Length is 275, and there will be a angle. Go to angle between. This angle is 45 degree. This much. Then go to revolve axis. This is my axis of revolution. Close sketch. Click 360 degree and then finish. And this side it is a chamfer. Here you can give 1 mm chamfer for that. Give 1 mm chamfer, and opposite side there will be a fillet. Go for round, give fillet for distance of 5 or 6. Okay, there will be a fillet, and save the part. Click fit, apply material here and save part. After creating all the parts of screw jack, we'll go for assemble the parts. Go to new, click on ISO metric assembly, then click show reference planes. Then in the left side there is a part library. Click on the part library and go to drop down menu. Choose the folder where you save your parts. Then see there are parts displays here. First I'll start with body part. Press and hold and drag and drop the body part. Once you drag and drop the body part, the first part is fully positioned by default. Now go for the second part. My second part is nut. Hold the left mouse button and drag it. Assemble the parts. Minimum 3 constraints we have to give. See, one is mate and second one is planar and axial, or you can go for directly flash fit. Either you go for flash fit or other 3 constraints. Now I'll go for basic method, mate, then axial, then planar. Click on the nut bottom face where it will mates actually to top face of the body. See, now it is mating. Now I'll go for axial axis. Can you see the highlighted portion of the hole, and axis to axis? Still it's not fully positioned. We have given 2 constraints. That for the fully position of minimum 3 constraints we have to give. We have given mate and axial, still planar. For show the planar reference plane, go to construction display here. Click on the construction display. Click on show reference plane of nut. See, this is the body reference planes. This is nut reference plane. Now you can align with this nut reference plane to the body reference plane. Now it is fully positioned. Same thing for the next screw spindle, drag and drop. For this also it's minimum 3 constraints. Go to mate, to click here the mate. Before giving the, since it is a threaded portion, you can place not exactly 0, or you can give at any distance. Suppose I place it at a distance of 50, then you type the distance. If you choose 25, then it will place above this surface to 25 mm. Now axis to axis, see there will be a 50 and planar. Go to show reference plane, click on any reference plane to any plane, not top to top. Click fit. See, if you click on screw, then if you want to change the height, suppose I'm editing this height to, instead of 50 I'll give 25. You can possible to edit it. See, or you can make it 0 also, since it is a movable. To assemble the next part is cup. The cup will come and seated here. Drag and drop the cup. Go to bottom surface and top surface of and axis to axis and construction. Show constructions, show reference planes, click the reference plane to reference plane. Then washer, click and grab, zoom, make the bottom to this cup top surface, and when you see the axis line to axis line, and show reference plane to flat to any flat reference plane. Right, now CSK screw, countersink screw, drag and drop, zoom. See, this top flat surface will come and mate with this top surface of washer, this axis to this axis. Then any flat surface, or you can go for construction, or you can directly have a flat surface here. Click on the flat surface in the slotted to this, or you can go for construction display. You drag and drop the Tommy bar here, give the axis, and no need to fully position for this one since it is a movable part. Move the part, show the axis and move and place. That is enough for the Tommy bar. Okay, now I will show one more easy method, that is by flash fit. Go to body, drag and drop. Now next nut, drag and drop the nut. Instead of going for mate, axial, all these things, all the three constraints, I'll just go for flash fit. Click on this outer edge and inner edge of the body. By default, see, it's a fully positioned. One more is spindle, same thing, drag and drop. If you click on this corner, by defaultly it will flash fitted. Otherwise, if you want some give distance, you can give any distance. Then click on this outer edge and click on this outer edge, then automatically it is flash fitted. For a cup, drag and drop, click on outer edge, click on top surface of edge. See, all are fully positioned. Now washer, this corner to this corner, and CSK screw, this edge to this edge. Now Tommy bar, no need to constrain, there is no corner to drag and drop, just insert and move. Only thing, this is not fully positioned. For Tommy bar, give axis to axis, move part, then this no need to constrain or fully position, like this by doing the flash fit. Now you save the assembly as a screw jack assembly. And keep it in isometric view. Go to file name, click right button, click create drawing, click OK. See here, there is a view wizard, drawing view layout. Click on that, which is the custom. If you your front view is not proper, then go to common views, click on and rotate position, what position you want the front view in the common views, and position it, then close, then that is my front view, and choose front, top and isometric views. Keep and delete. I want to sectional front view, then go for cutting plane, click top view and construct the cutting line from center, zoom, and from the center. Suppose I want to cut see, this is the cutting plane. I want to cut this portion right off in section, and close cutting plane, show the arrow upside. I want to place my section plane above the cutting plane. Then go to section, click on this line and place where you want the sectional front view. This is my sectional front view. And general, basically the fashioners you are not supposed to making hatching. Then go for right button, click properties. Here you go for display. Then unselect the suppose tummy bar you are not supposed to section. Then screw spindle you are not supposed to section, and CSK screw you are not supposed to make section. Which are all the parts you don't want to make section. Click apply, then select that. After editing, click update views, then automatically it is updated. Tummy bar there is a knurling option. Go for the knurling. Here you go for fill, and one more opposite side, it is 135. You show the knurling like this. Part list, click on front view to mark a parts. Right now, no, I don't want the author. Go for properties, go to column, remove that author, then add material column. Here is the material column you can add, then apply. If you don't want that count, this is the part number 7 and the below one is the count. If you don't want that count numbers, press Ctrl and select that balloons, uncheck that count, then the count will be, uncheck the count item, only you will get the. Then this is my 2D draft for screw jack assembly.